Welcome to our lesson 5 of Ionic Equilibria. We are looking at weak acids, and in this lesson 5, I want us to look at the effect of groups attached on the carboxyl carbon on the value of Ka, or rather the strength of an acid. We've just seen that Ka value is a measure of the strength of the acid. The bigger the value of Ka, the stronger the substance as an acid. But then you realize that when we look at many of these weak organic carboxylic acids, the groups attached on the carboxyl carbon, this is the carbon we are interested in, carboxyl carbon. The groups attached will vary, and these groups will determine the strength of the OH bond. Remember, in the previous video we said the strength of the acid depends on the ease of release of the protons, which in turn depends on the OH bond. And we are now saying that the nature of the groups attached on the carboxyl carbon could be electron withdrawing, or electron donating. Electron withdrawing groups, we are going to abbreviate them as electron withdrawing groups. And electron donating, we are going to represent them as electron donating groups. Now, when we look at our carboxylic acid, R could be an electron withdrawing group attached on the carboxyl carbon. And then it could be R as an electron donating group attached on the carboxyl carbon. Like that. Now, let's begin with the electron withdrawing groups. Electron withdrawing groups always have what we call a negative inductive effect, meaning they have ability to withdraw electrons towards themselves in any covalent bond. So if we had the electron withdrawing group bonded to the carboxyl carbon, the tendency is that electrons in the covalent bond between the carbon and the group of atoms tend to move towards the electron withdrawing group. Now, this decreases electron density around the carboxyl carbon or carbonyl carbon, carboxyl carbon, and the decrease in electron density also results into weakens the OH bond, such that after weakening the OH bond, then the bond readily breaks to release the protons readily. And once the protons are released readily, then acid strength increases meaning Ka value increases. What are some of these electron withdrawing groups? Mainly these are halogens, e.g. the halogens. So you will have like a chloroethanoic acid. In this case, the chlorine atom is an electron withdrawing group. Its presence here makes it electron withdrawing, and so it will decrease the electron density around the carbonyl carbon or the carboxyl carbon, and the effect will be transmitted into the OH bond, and the OH bond will become weaker. Once it is weaker, the substance readily releases protons and it is regarded to be a stronger acid. It could be a bromine, it could be an iodide, whatever. These have a negative inductive effect. Now, electron donating groups have a positive inductive effect, and therefore if you had electron donating groups bonded to the carboxyl carbon, they tend to donate electrons towards the carbon atom, so that for them they become positively charged. And this effect increases. This effect increases electron density around the carbon atom, which also weaken, now this time strengthens the OH bond, and so acid strength decreases. Acid strength decreases. In other words, the Ka value decreases. Like that. So meaning that if we are given two values or two acids and their values of Ka are given and they are different, then one of the ways we can explain the difference in the values should be on the type of group attached to the carboxyl carbon. Let's look at examples. Examples we are going to consider. Example, the values of Ka, the Ka value. Let's look at the substance ethanoic acid. Ka value of ethanoic acid 1.7 times 10 power negative 5, and methanoic acid, which is 1.7 times 10 power negative 4. And we are tasked to explain the difference in the Ka value. We shall be saying that this is now an explanation. We shall be saying that methanoic acid is a stronger acid than ethanoic acid. Now this is in line with the values. These values, this is 1.7, 1.7, but this is power negative 5. This is power negative 4. So negative 5 is smaller than negative 4. And so this is a bigger value. Now the substance with a bigger value of Ka is a stronger acid. So methanoic acid is a stronger acid than ethanoic acid. And then we are tasked to explain. Now in the explanation, we look at the groups attached. We have this group, and then there is a hydrogen atom. Now, methyl groups tend to have what we call a positive inductive effect, and therefore they are classified as electron donating groups. So we shall be saying that in ethanoic acid, the methyl group are attached to the carboxyl carbon has a positive inductive effect. Positive inductive effect tends to push electrons towards the carbon atom. Increases electron density, which in turn strengthens the oxygen-hydrogen bond, which in turn strengthens the oxygen-hydrogen bond that it doesn't readily break to release hydrogen ions in solution. While in methanoic acid, the hydrogen atom attached to the carbon atom has no inductive effect. Hydrogen atoms have no inductive effect. Therefore, doesn't or does not affect the electron density and strength of the OH bond. Has no influence on the strength of the OH bond. Another scenario would be if you had ethanoic acid And then chloroethanoic acid. This is 1.7 times 10 power negative 5, but this is 1.3 times 10 power negative 3. Clearly, if you look at the powers, negative 3 and negative 5, negative 3 is a bigger value than this. And so, chloroethanoic acid is a stronger acid than ethanoic acid. And that all goes to the chlorine atom attached. The chlorine atom. So the chlorine atom, because we already know now about ethanoic acid. Well, the methyl group has a positive inductive effect. The chlorine atom has a negative inductive effect. Tends to attract bonding electrons towards itself. Decreasing electron density around the carboxyl carbon, which decreases the strength of the OH bond. Decreases the strength of the OH bond. Now, once the effect decreases the strength of the OH bond, then therefore it readily breaks to release hydrogen ions in solution. Breaks to release hydrogen ions in solution, making it a stronger acid. So the type of group or the nature of group attached on the carboxyl carbon could either be electron withdrawing or it could be electron donating. Another case that would readily come up would be in phenol. If you looked at the structure of phenol, phenol has a benzene ring. A benzene ring attached to the oxygen with the OH group or the OH bond. Now, what does the benzene ring do? The lone pairs of electrons on the oxygen atom tend to interact with the pi bonding system. There is donation of electrons to that carbon atom, and electrons get in motion. Now, this tends to strengthen the carbon-oxygen bond, but weakens it weakens the oxygen-hydrogen bond, meaning that the effect of this again is to weaken the OH bond. Now that makes phenol a stronger acid than other alcohols. And so that's the effect of the groups attached on the value of Ka. In the next lesson, we shall be now looking at how do we calculate the values of pH using the Ka and other things. Thank you for watching.